Okay, so with this short video and a very quick resume, you know what were the objectives of the project and what kind of companies form our consortium that we've been working on this project over those years. And right now, I would like to invite our project officer to direct a few words and officially launch this event. So, Alberto, the floor is yours. Just give us a video presentation.
Thank you very much. And good morning, everyone, and welcome. Today is a very important day, I believe, because we published the goal in 2020. As a result of that goal, we have the SH2E project, and after 3 years of hard work, we have today the final event, in which we are going, I guess, to see the works that we have performed, but also the outcomes of this work. For us, sustainability and circularity is very important. And indeed, I prepared a few slides in which I would like to provide an overview of the different activities that we have within the partnership. Thank you. Just for those who are not familiar with the partnership, just let me start by saying that we are an institution of the European Union in the form of a PPP, a public-private partnership. The partnership is composed by the European Union, represented by the Commission, and the private side is composed of Hydrogen Europe and Hydrogen Euro Research, representing the industry and research group working on hydrogen and fuel cells in Europe. And what we do is we implement a research and innovation program for a budget of 1 billion euros from Horizon Euro Research and Innovation Framework Program, which has been topped up with additional 200 million from the REPowerEU communication to double the hydrogen values in Europe. If you are interested, next slide, please, if it's possible. If you are interested, in any case, to know exactly what we want to do or what we do over the next few years until 2027, officially 2031, it doesn't work. I would recommend you to have a look at one of the main documents that we have in the partnership, that is the Strategic Research and Innovation Agenda. Here we have summarized what we're going to support, what type of technologies, what type of activities are important, and have been agreed between the Commission, Hydrogen Europe, and Hydrogen Research as the strategic push in research and innovation for keeping Europe at the forefront of these technologies. We are supporting research and innovation activities along the hydrogen chain, from renewable hydrogen production, storage and distribution, and end uses. These are complemented by a set of horizontal activities, cross-cutting issues, hydrogen values, aspects related with the supply chain of challenges of strategic importance in Europe. All these activities are mainly conducted through projects. You are essential for the success of this partnership. You are essential for pushing the hydrogen technologies in Europe forward. But all these technologies are complemented by other activities, let's say, that we are running in the program in parallel to the projects, like the synergy with other partnerships, the collaboration that we have with the JRC, the RCS Strategic Coordination Task Force, the Safety Panel, Circularity Panel, and so on. I will mention it later. The main instrument that we have are projects. You are essential. You are really building the partnership. You are pushing the technology forward. And just to give you an idea, over the last years, since 2008, we established as SH2E1, we continue on SH2, and this is the third, let's say, program of hydrogen technologies. We've been supporting 372 projects for a little bit more than 1.5 billion. And you have here the breakdown. We have been supporting many projects in production, renewable hydrogen production, many projects on end uses, and lately, very popular hydrogen values is one of the main instruments that it's a very welcome, and supply chain and so on. And in cross-cutting in particular, that the area that I had the pleasure to coordinate, we try to concentrate all the challenges, or we try to address all the challenges of horizontal nature. They are not related with the technology, they are not related with a specific application, they are horizontal. And we agreed to work on 3 lines on actions. On sustainability and circularity, because of course the technology needs to work well, it needs to be cheap, but it needs to be circular and it needs to be sustainable. Otherwise, they will not prevail in the long term. So we believe that it's time to start working on sustainability and circularity. The SEA project is one of the projects that we are supporting in this area. Education and public awareness, because we need to prepare the workforce that is needed for the rollout of these technologies in Europe. And of course, safety, the research and regulation costs and standards in order to make sure that we have a regulatory framework suitable for hydrogen so that it does not block, say, the rollout of the technologies. As I said, we are supporting grants, projects, let's say it's the main instrument. You are one of them. The SHE project is one of them. And we have three main objectives within the sustainability and circularity, let's say, area. One is to develop life cycle thinking tools, LCA, social LCA, LC sustainability assessment, all these tools that helps to assess the technologies in a holistic way, taking into account not only the economic or the environmental aspect, but also the social, which are becoming more and more important. We are also supporting projects to develop eco-design guidelines and eco-efficient processes, and to develop a recovery process in order to make sure or to work or pave or build the foundation that the sector is recognized as a circular, a sustainable sector. Beside of that, as I said, those are projects. We have other activities running in parallel, and I would like just to share with you that we have a lot of activities with the JRC, the Joint Research Center of the Iraq Commission, particularly on sustainability. I will go through it in a minute. And the last initiative that we have launched, because we are very committed on circularity and sustainability within this program, is that we have launched the European Hydrogen Sustainability and Security Panel, which is mimicking somehow the safety panel that we have since 2016. And it's a group of experts that they will help us to steer and to strengthen the sustainability and security aspects along the entire program, not only in a particular project or particular projects like in cross-cutting, but also for the other projects. Concerning projects, very briefly, we have been supporting 8 projects so far for a little bit more than 9 million, involving 10 million projects, 10 million and more than 10 countries, sorry. We're starting with the project SC2E, which developed the life cycle assessment, the first guidelines in the sheets, let's say the follow-up of the HAL guide project. We have supported the high-tech cycle in order to assess what type of technologies for recycling and dismantling are available, and of course certify in order to guarantee that when we talk that the hydrogen is renewable, there is a solid and robust system behind, so that we are sure that when we say it's green, it's low carbon, there's a methodology agreed between everybody, so that we can label it properly. Now we have 3 projects running. Unfortunately, the SHE project is ending now. The eco-design and the project ECOS on eco-design is also ending now. And the base for high, all these 3 came from the core 2020. So all these projects are about to finish. The SHE project we will hear today. Base for high is the confirmation of high-tech cycling in order to assess and try to recover as much as possible the critical raw materials and the substances within the technologies. And within the Horizon Europe, as the Clean Hydrogen Partnership, we have supported so far 2 projects. One is the HYPEF, which is which aims to develop the product environmental category footprints for some applications. And the last one is HIRA, which is going to make an inventory of the potential releases, desired or undesired releases of hydrogen in the expected hydrogen economy, so we can assess if this hydrogen has a real impact on the climate. Besides that, we have a lot of collaboration, a lot of activity with the JRC. We've been holding expert workshops. Indeed, in 2021, we held one workshop to fine-tune what was needed for the SHE project in particular. They have been working with the SHE project to develop the LCA checklist to make sure that both the LCA checklist from the JRC and the SHE guidelines are aligned. And the checklist is one of the tools that we are going to implement at the program level. We are going to ask from now on that every project that performs a life cycle assessment, they have to provide information according to LCA checklist, which is, let's say, based on the SHE project. Just to see a little bit the strategy behind how everything works together. And of course, with the JRC, they are also working on different aspects which we believe are important, like trying to let's say build a conceptual framework for the social aspects, which is maybe the part that is not so strong as the others. As I said, the Security and Sustainability Panel is the last initiative. This is a picture from the kickoff a few months already, no, ago. And as I said, it's a group of experts that will help us to increase how we to make sure that sustainability and security are taken into consideration in all the projects, not only cross-cutting on this type of projects or LCA, but also when you develop that technology, maybe we adapt with a recommendation that the project may need to do a prospective LCA in order to make a decision which technology, which material they need to select so the technologies are becoming more sustainable. We will see. We have just starting, and we have great expectations because we do believe, and the Commission always repeats, the technologies that needs to be singular, otherwise not prevail in the long term. And that's it from my side. I will not take much time in the day of the SHIP project. I think we will hear many things, many good things. I would like to invite you just to visit the website where you can find all the information. Subscribe to the newsletter if you are interested. And of course, I would like just to invite you to the main event that we hold in Brussels, the Half-Year Week, at the end of November. And with this, that's it from my side. Thank you very much. I wish you a great final day. Thank you.
Thank you very much, Alberto, for such a nice inauguration of the final SHE event, and also for introduction of the Clean Hydrogen Partnership. And with this, we would like to continue. And our second speaker, I would like to.
How do we do this when we have How do we do this when we have questions? We collect them until the end or ask them after?
If you wish to ask a question, I think this is the moment.
Yeah, I was about the external panel. That's very interesting, but it's also a bit challenging, I think, because I've been invited to some panels also from the GSC, and often that we see there's 500 people participating there. First day, I think. And therefore, it's either that you have a company that wants to push technology, or software, or other form, or whatever. After that, if others dominate and take decided other company use this discussion or progress over a certain method in mind and want to push this somehow. But it is a bit, so people have a strong interest in participating there, and therefore it's very difficult to get a really unbiased, open, collaborative spirit in this, when you don't pay for people to spend their time on this, because they do this to get something out of it. So how do I work so far?
Basically, the works are reimbursed according to the expert contract that we have. At the city planning, for example, right now, you work as an expert because and they work as independent experts, as natural persons. They do not represent their organization. We don't want to that there is a bias, that there is a commission interest. We want that experts who that really know the tools, the technology, help us to make it better. And that's the idea. They have been looking for different task forces, one at the project level, one at the pro level, and the project level, for example, we do expect recommendations of how we can improve that the projects are really getting the sustainability from the beginning, not at the end, just to check that the technologies are there and they will work whatever they want. That's something that we have heard from this program right now. And when they report on the life cycle assessment results, they report some indicators, they will report about the methodology, they will say how everything. There are many things that they avoid us to compare the answers also to show the progress that this finding is making thanks to the activity. So the idea is that they will be working on different aspects, project level, program level. There is a group of cross-cutting and non-mistaken, and they work as independent experts, and see we can manage to get something.
Thank you very much. So it's only one policy because they work and communicate.
There are any more questions? If not, I think we can now follow with the presentation of the project coordinator for the first fire room.
So good morning, everyone. Thank you for participating in the final event of the SHIP project. So this is just, we will see just a quick summary of all the activities that we have performed in the last 3 years and a half. Before beginning, I would like to also to take this opportunity to thank all the partners in this project, because it was difficult at the beginning. You remember the COVID time, we were just at home trying to develop a new guidelines and so on. So it was the starting out was a bit complicated, but we have overcome on these barriers and we are reaching the. Oh, I got that I missed one in the presentation later, but yes. So this is just the administrative information of the project. As Alberto has commented, we are awarded in the fall of the 2020 under this topic. This is the total donation for the project. As commented, we are coming to the end by the end of this month. We have the total budget, and you can see that the total budget is a bit higher than the contribution coming from the Clean Hydrogen Function. This is due because we have incorporated here a partner from Japan that they have its own budget. And I want to express also my special thanks to the Institute of Applied Energy in Japan, because you know it's not so easy just to collaborate in the distance and also with this thank God. But it was, I think that our collaboration has been really fruitful for both sides. So that's a quick project summary. These were the main goals of our project. Just the first one, just to provide a well-defined, practical framework for life cycle of fuel secondary systems. We intended in this project just to produce a very practical tool in the form of guidelines, or also a software tool that we present later, to support the fuel cell and hydrogen sector, and especially the research projects coming from the clean hydrogen pipeline system. In this way, also this framework that we have developed in the project was aimed at to facilitate this robust decision making about this criteria, including super criteria among all other decision making items. And finally, we have focused in the development application of the specific guidelines for the environmental, economic, and social life cycle assessment, LCA, HCC, and LCA, and of course, marrying all of them in analysis and sustainability assessment framework, and all of this supported by this software tool. This is just a picture about the history of the project. As Alberto has commented, we built all the results coming from the HyGas project, the FCA HyGas project, and also from this tax from the International Energy Agency, the Tax 36, the Post on Life Cycle Assessment of Hydrogen Energy Systems, where some of the partners in this project also participated. And there are other different inputs coming from the guidelines of the document from the NEPSEDAC, and also for the ISO standards. So coming to the results, in this project, we have developed different guidelines, as I mentioned, the life cycle as also the SC, the social life cycle assessment. We have also proposed a material critical indicator focused in the hydrogen and in the European sector. This is different with other criticality indicators because our aim was just to be focused on the hydrogen sector. And finally, all of these have been managed in these life cycle guidelines. And of course, we have the tool. So I have some pictures. I want to make any spoiler to my colleagues for the next presentation, but just some insights in the different parts of the project. This is just some templates that you will find in the tool that we have developed in the C project. It's about to include the prospectivity, because this is an important aspect of our project, because this is the standard we have included this prospective approach in these life cycle studies. Because as you know, many hydrogen technologies are until 5, 6, and they will reach the maturity in the market, let me say 10, 15 years, depends. So it's important just to make for analysis and comparative analysis, just to make this prospective approach, just to see how they will perform in our world. So we'll see later in the guidelines, and also in the tool, we can define different system boundaries depending if we are in the production use or both of them. We have also here included the end of line and different ways to deal with it. It will be explained later. This is one of our contributions in comparison to previous projects because we have included here the end of life states as far as we can because there is not so much information about the end of life of aliens. Yes. Finally, this is just the final selection of the template. So we will get a tree or a diagram, a block diagram like this once we have filled all the templates. So we have also checked all these guidelines with 2 case studies. The first one was the kind of production with a solid sodium electrolyzer that is coupled to a CSP plant. And the second one is the hydrogen use in a prototype electric car. There are some results here, but they will be explained later, so I will not go into detail of that. But for instance, you can see here how the carbon footprint is decreased, and all of them are calculated by the harmonized way. So it's totally comparable in this case. Coming to the hydrogen use, this is the tree, the CP or the program that we built in our tool, and also some results about the different environmental categories that they are mainly based in the European, the environmental footprint 3.1, that is the methodology that was proposed by the European Commission through the JRC. I think that if we are working in a European project, I think that we have to implement this method. And okay, that was all. I don't want to just begin this project to the next presentation. So again, thanks to all the partners and thanks all of you for attending this. The question later on. That will come on to the
A question. You mentioned the physical indicator that we developed, and this indicator is kind of a complementary indicator to the one that developed with respect to the one developed by the information GSC, or
actually, I think that for studying criticality, we need to study different indicators. So I think that the indicator that we are proposing in the project is focused in the internal European production of first and secondary production. We take also into account the possible supply point for us in the coming, but just for Europe, not for the other countries. So this is my opinion. Working there is, I think the information from our indicator is quite complementary to the geopolitical indicator. I think if we can merge the information coming from both indicators, and in any case, Petra will explain this indicator in more detail. Yes.
Looking forward to it.
Okay. Any other question? No? Okay.
Don't worry, okay, we have many more questions for you saved later for the discussion panel. So thank you very much. And with this, right now, I would like to invite our colleague Petra to give a better and more profound overview of the life cycle thinking. So Petra, the floor is yours. Thank you very much.
Yes, thank you also. So I will now take you through our specific guidelines for life cycle assessment, life cycle costing, and social life cycle assessment, which were developed. And I would just give a brief introduction what we were doing or what our objectives were, and then go with some examples into each of the 3 dimensions, and also what we did with this, what the following up steps were with this. So when we said we will look at the entire life cycle, we really includes as normal the life cycle for specifically fuel cells and hydrogen systems. And in many of our recommendations, we make a distinction between technologies which produce hydrogen, so the production of hydrogen systems or the hydrogen producing systems, and those which use hydrogen, so the fuel cells, vehicles, or whatever because difference or different aspects have to be highlighted when we look at these two sides. So as you've heard already, the guide or the objective is to develop this sustainability guidelines, but they are based on specific guidelines for environmental, economic, and social aspects. So which we looked or started with at the beginning to look in these dimensions and to develop specific guidelines, which then will be integrated in the sustainability aspect. So we started with environmental guidelines, looked at costing, livestock costing guidelines and social guidelines, as I said, to combine them for sustainability. So we had many deliverables, but I now will focus on the first three, like life cycle assessment, life cycle costing, and social guidelines, which are separate guidelines introduced in the project. And as all partners have somehow contributed to all these guidelines, it was let's say a bit easier to see that they're really following the same structure. So within these specific guidelines, you always find this executive summary, the content list, and then we have general information describing how to read these guidelines. And then this more specific parts depending on the dimension for economic, environmental, social aspects, but following the same structure. And here you see it for the life cycle assessment. This specific guidance part is the main part of each deliverable. And there we go, dive more deeply into these specific aspects, and it is common for the guidelines here. So what is also done within, or what you can find in this guideline, is that there is a description of the topic, and then you have you can find three kinds of boxes. The green boxes really summarize, focus on requirements which have to be done when you do a life cycle assessment. Then we have blue boxes. They give recommendations, so it's not necessary, but it would be helpful to follow these. And then we have some yellow boxes where we give more information, so describe how things can be done, where to find stuff. So you really find within each of the deliverables these green boxes where you can easily see what needs to be done, what could be done, and the explanations are often more complex and give more information. So that's really the structure for all three guidelines. And we also try to give some advice how mature the methodology we propose is already existing. So with every step or with every topic in such a guideline, you find a symbol saying that it's very mature, you find it in software, you find data for it, or it's a first idea that may be recommended, so that the practitioner can already see where to jump in easily or where to look for more information. As I said, we have been partner in most, or everyone has been partner in describing this, so we really wanted to make these guidelines symmetric, but anyhow, there are some topics which are specific for social, for environmental, for costing. So it's not always possible to have this overall harmonized approach. So specifically when we come to this combination of all the three topics, that has to be recognized, but that will be also explained later when Kafi will go to the life cycle sustainability guidelines. So starting with the environmental part, of course, there are already existing guidelines. As you heard already, there is this baseline guidance like ISO, the environmental footprint, and the ILCD handbook, but we have this fuel cell and hydrogen specific guidelines already from the HyGuide project, which is now about 12 years old or something like this. So there had to be done an update. And as we were mentioning earlier, we also had this IEA task where we started to look not only at the environmental part, but also at cost and so. So with the objective for this environmental life cycle assessment was here to update the already existing specific guidelines, but also to implement the criticality indicator for critical materials, and also to implement a way to look at prospectivity. So that were the two main additional topics we included in the guidelines. So coming to the criticality indicator, we wanted to introduce an indicator following the life cycle impact assessment logic, so creating a characterization factor. And of course, we wanted to integrate also the methodology of the European Union. So not coming up with a totally new indicator, but using the critical raw material list of the European Union. And we had a long and fruitful discussion with the JRC about how to integrate it and how to use it using just the indicators as they are in the European DRM list, or introducing a new part. So what we came up with in the end was that we use information from the European critical raw material list, or from the reports of this critical raw materials, so that we look for the supply list of a specific material, and we also look at the consumption of this material. So it's not only the supply risk, but also the consumption. And we stated that consumption is only a problem if this has to be imported. So if the import reliance is quite high, then a high consumption is the problem. And also if there is a possibility or the opportunity to recycle the material after end of life within the European Commission, then the consumption is not that critical. So we came up with this new, somehow put together characterization factor, and we recommend to use this for all the foreground materials in the foreground system, because we also looked at it when to put it in the background system, but then you come up with a lot of critical materials like steel or something like this, just because of the mass in there. And so we said we concentrated on the foreground system. We recommend to use the data, the newest available data from the CRM list. So the last one was from 23 to include this information. And we also tried it for a hydrogen producing system for 3 electrolyzer types. And this is one of the results, where for producing 1 ton of hydrogen for different alkaline PEM electrolyzer and solid oxide electrolyzer. And what you can see, and which is in the discussion, we find it that iridium is of course critical material for the PEM electrolyzer, and for the SOEC it's gadolinium, which is causing a major problem. So that's the criticality aspect. The second one, prospectivity. Here, as Sophia was already saying, we have quite often low TRL level. So we want to integrate prospectivity, which hasn't been a topic in the HyGuide guidelines before. So that's a new topic. So we recommend that it should be integrated, or must be integrated, the green box, to look at the future. And also here specifically the foreground data for the technologies should be, or should give the data for future systems. And when you compare systems, it's also necessary to see that they are that you have data for the same time in the future and not comparing it on different time levels. So that is one of the green boxes. We also have additional recommendations here, so that we say it would be helpful also to include it for if you look into the future for the background data. There are some databases already give you information like premise, for example, and also really to the RAL level or the manufacturing readiness level to be sure that you compare it on the same level. And also, we here now state that we recommend to look at scale effects, to look at learning phenomena, and how to do this is then described in such a yellow box where we give some information how to scale what is normally done, what are learning phenomena which could be considered. So that information can also be found as an example in the guidelines. So coming now to the costing guidelines, here the objective was to define economic life cycle indicators or to give appropriate set of or single indicators which should be considered. Also the evaluation methods behind these indicators are given. Here for the costing, it is also important to look at the perspective of the stakeholders which is involved, and also here we have the prospective aspect included. So as I said, the stakeholder perspective for costing is quite important because you have you should make a differentiation between whether the view from a producer, the view from a consumer, and the societal perspective, because that has an impact of a lot of financial and fiscal aspects. So there is a differentiation between these stakeholders, and that also means that you, depending on the stakeholder, have to include other data to describe the categories or the indicators. Another point we see as mandatory is to apply discounting. So especially if we see the development in the last years, inflation is becoming a topic which hadn't been a topic earlier, was quite stable, but now we see that we need to include this. The discounting should be applied or must be applied, and we also give information how to reach it and how to get the information and where to get the information. Economic indicators we recommend, depending on the perspective, is for producers. You would look at the life cycle cost of hydrogen, which include the capital operating fuel or the electricity and financing cost for the producer. So that's the indicator you would choose when you want to describe costing for the hydrogen production. If you are looking at the consumer, like the fuel cell cars, you would look at total cost of ownership, where you look at all the costs which a consumer has to pay, like purchasing, deploying, using, but also retiring of the product. That there you have combined this in the total cost of ownership. And if you look from an investor side, here, of course, the net present value is a very interesting indicator which should be considered. So depending on the stakeholder, we would recommend different kind of indicators. Also, prospectivity here is mentioned. We have for the scaling, there is this typical rule of thumb where we, from the engineering side, often use 0.6, but there are already other figures for the costing existing. You find several other data in references. And you could also include learning curves which are available, so learning rates, which then define how much the capital decreases when the production is doubled. So that's what's meant behind this learning rate figure. So this is also described in the life cycle costing guidelines, and it also gives the cost breakdown structure. So what has to be included if you're looking at life cycle costing, which is something which is different to the others, is that also the knowledge development. So R&D is included in the costing parameters, which is not done for the life cycle, for the environmental and social part. So here you have to include this this part of the life cycle as well. And if you're not able or you don't want to, you have to verify why you are not including the entire life cycle. Coming to the social part, here the main focus is on the definition of supply chains, the social aspects connected with supply chain, give information about what are typical sets of indicators for social aspects, and also the prospectivity here is mentioned. For the social, we are coming back to this traditional life cycle from extraction to end of life, so no research and development. And also here you need to include the background processes for different kind of level and their aspects. Data, we provide where data can be found, most often are statistics, so like World Bank, International Labour Organization, or World Health Organization, but you also find data in governmental databases, in private databases, and there are coming up several studies now for social aspects combined with life cycle, with fuel cell and hydrogen systems. So some studies are available which show this or values for this thing, but in the guideline there is a link to this product social inventory lifecycle assessment, CIRCA database. We recommend to use it, which is an available database for social data, detecting social hotspots, or it helps to detect social hotspots. It calculates the social impacts along the entire life cycle, also including supply chains. And the backbone for this database is economic multi-regional input-output model, describing the interdependencies of different industries or different commodities worldwide, so that you get information where industry, specific fuel cell industry or hydrogen industry gets the supply from. There are several 189 countries represented in this data in MREO database behind this. So the connections between these countries, and you find these specified for sectors. So it's not a specific factory, but it's a sector. And when you find that there is a social hotspot identified, then you can step in there at this point and look more clearly or more closely to this specific point. So because it's an economic database, and monetary processes or the connections are described in monetary processes. So this is a CIRCA database. We describe prospectivity set is also mentioned, because here again, is a typical or an exception for the social part. Even if we describe the fuel cell system in a future perspective, the current or the social aspects are the current situation, or because it's statistical data, even past situation. So what really has to be done is to describe that there is a difference between the future aspect of the technology development and the today or past situation of the social aspects, because there is no prospective database on social aspects available at the moment. So here we have really this green box limitation that we cannot address future social aspects in a database. But what we can do is that we can look at the development of the technologies, of emerging technologies, and relate it to current state social aspects. And how this can be done is also described in a recommendation box, where we say that the technical data should always be a future set of data, but we have to be really sure to state that the social data are from today's perspective. And also we recommend to really show from today's perspective of technology and future development in the technology, and see how the social aspects will change by that. Then the assessment, the impact assessment, is done according to life cycle assessment in the environmental part. So we look at different kind of stakeholders. Here it's the example of workers, because there are the most information available for workers. Then we have so-called themes describing different topics which have a connection for this worker stakeholder group. And for each theme, we then have social indicators describing this specific topic. So this is following the impact assessment is following the structure of environmental assessment. So what I've shown you, that we have now 3 guidelines for the specific dimensions. All guidelines have been checked in case studies, which will be presented later. The next step is to bring them together in this integrated life cycle sustainability guideline. We will show you in a minute. And what we also have is the mentioned software tool, where the information go into the software, which will be presented by Andreas later. So we started with this 3 different guidelines. We have spent most of the time actually for the environmental part, although this is the most natural one, but we had to really bring our ideas together, see what's available, and then it got a bit more easier for the other guidelines, because as I said, we worked all together on all 3 guidelines. And what you can do, you can find a final, not the final, the final, how do I call it, guidelines on our page. So after the approval by the officer, they will be finalized in the end. So it's a draft, let's say, final draft probably. So if you're interested, you can find each of these on our homepage. Yeah, and before you get more information of the sustainability and the tool, I'm happy to answer questions concerning the specific guidelines. Thank you.
So if there are any questions, I think we have to answer 1 or 2. If somebody would like to ask.
Yes. Yes.
I can ask so about, it's more common about the prospective social SA databases. That is, of course, I think there is not really a methodology yet how to assess future social impacts. We presented just in the social SA conference in Brazil 2 weeks ago or so, an idea how to capture this, because we need to, for one, of course, we need to have some of the economic development in 10 years or so. It's reflected in the database, but then also how the social impacts change. And then realize some social impacts are rather depending on the management of the company, so it's impossible to predict them. Discrimination also if this happens, because we don't know how the company is running in 10 years. Some depend on the context. So is this country at war now or not? This of course has a lot of impacts, and this is also, I mean, we need to maybe can guess this, but it's not straightforward, as everyone probably agrees. And then some things also depend on the policy, and these are easier to predict. And so we have developed a proposal, but and present this quite some attention, but it's a bit really therefore it's quite understandable. I think that for now we say this thing also there's no database we can press a button and then we get future research and the most consequential let's say, but in database, but it's also a bit doubtful how to use that. And so therefore this will come, and I think it's fine that we have not addressed this in the method. So
Yeah, I think that was a discussion behind that. It's too early, far too early. I mean, we had the same with the environmental parts 20 years ago, 30 years ago. And it took some time, and I'm sure that we find some solution for the social as well, but not within this guys like that.
In the beginning, we have categorized the users into producers and users.
Yeah.
Can you please speak about transfer and distribution? Would you add this into one of these categories? And if not, what would be the applicability to the, let's say, projects that you do with the financial transfer and financial distribution?
Well, of course, it depends if your producer, if you're selling it on your gates, or if you're also applying transport, then I would rather put this in this life cycle levelized cost of hydrogen. That should be included there. But if you are a user, purchaser, and you have to go with your fuel cell car to the station and get the fuel, get the hydrogen, you should include it there. So you have to describe your system boundaries quite clearly, and then you can include it in either one or the other, but you have to describe so that you're not double counting it. But then it's fine to put it in one or the other. Yeah.
Maybe a philosophical question regarding the clinical indicator, but curiosity, just how do you under which pillar of sustainability did you put the clinical indicator?
We have put it in the life cycle assessment pillar at the moment, and there in the impact assessment methodology part. But it is stated that because it has some influence from the costing and the social parts in there. So we have stated that it should be considered, but the description of the indicator is at the moment in the impact environmental assessment part. But you're right, more than overtaking.
I put my side about the guidelines, because I understand that the guidelines will guide actually practitioners for less experience, no? In the field. But I wonder about the beginners, some of the not many years behind the working on it. Do you think that they can follow the guidelines, or we really need an in-depth knowledge to understand what's all about?
We have tried to make it also readable for beginners. I'm sure that in the tool it's even easier for beginners because you're guided through it. So that's taken into account also that people practitioners probably don't know what step to make. Yeah, as guidelines are, you have to often have some backgrounds to understand them, because it's just a summarized version of the discussion. So that's with every guide, and otherwise you would have guidelines which are, I don't know, 500 pages thick, and no one is using them. But I think we try to make it also easier or easy for persons.
Maybe to add on this, I support this, of course, but I think we have a quite complicated case, because hydrogen can be used in so many different systems. So if we say fraction of glass water bottles, then it's quite easy to make a model that allows non-expert to change some parameters and still maintain a valid model based on the business. So, but hydrogen can be used in 12 different ways, can be used in 12 different ways, and you have transportation in different ways in between. So therefore, basically, it's all about lifestyle assessment. So that makes it more difficult to make a non-expert accessible version. We have wizards there, including wizards in the tool, so that you are guided, but if you have no tool or anything before, it's I think very challenging.
Like to comment also, because the reason behind using these green boxes, boxes was just to make more friendly to beginners or lifestyle. And a second comment is also the environmental guidelines were aligned with the LCA checklist coming from the JLC, because it makes sense that these two tools, these two support documents are aligned and we are in the same line.
Okay, so I think with this maybe we can follow with another presentation. Thank you very much, Petra, for such a nice introduction of the guidelines and propounding of all the work that has been done. I think that you can see that it has been like an ice deep.
Wait, let you stop talking so that you can start the chat.
Please go ahead. So I think with this, maybe we can proceed to the presentation of Javier, who will actually give the presentation on the specific case studies that were also a key point of.
So, just coming to the merge of all the three previous guidelines. Okay, can talk about the Sustainable Development Goals proposed by the United Nations. The aim behind this license assessment is to address the most of these indicators that are proposed. So, if we talk about sustainability, for sure we are talking about quality of water, energy, and so on. But also, since we're introducing these social and economic issues, we are just addressing, for instance, poverty, other activities like responsible labor, and so on. So, as Petra has presented, now we are talking about the life cycle assessment. Is the combination of the three previous guidelines. You can see all this information in this deliverable that you can download it from our web page, as was commented previously. And the objective here is already mentioned, is just to provide these robust guidelines for life cycle assessment. But again, just focusing fuel cells and hydrogen systems. So, but considering integrating the life cycle assessment and second cost and social life cycle guidelines that was presented. So we are here, just one of the final outcomes of our project. And as it was just presented by Petra, one of the main aspects that we addressed when writing these guidelines was to take into account the differences and the common aspects of the three previous guidelines. So, for instance, For instance, we have different scopes on the three guidelines. We can talk about the environmental issue. Just talking about productivity is not the same way to address for environmental and social aspects. So then we spend a high amount of time just trying to identify the commonalities and acceptable discrepancies, because it was just a matter of waiting to please the best for these target systems. We follow the same structure as previous one, just to make easier the understanding of this guideline. We use the green boxes when the requirement appears. These blue boxes was just related to recommendations, and the yellow boxes was just for supplementary information. And for instance, one, let me say, controversial aspect in life sustainability assessment is just address the multifunctionality, because sometimes it's a bit tricky. Yes, you consider different aspects. So in any case, we indicate here that the multifunctionality approach selected by the full study of sustainability must be consistent across all the sustainability dimensions. This is one important factor. And then we follow that in the case of the standards. So this must be preferred. So you can apply system expansion is the preferable second option. This is just following the standards recommendation. And then we make here one categorization or selection or prioritization of the approach to be followed, just to allocate the current aspect. So then if system expansion is not possible in environmental life cycle social assessment, then we should look for a physical allocation based on energy content, when only energy flows are the main outcome of the project. If not, we propose just to follow the number of moles. If not, we propose to use the economic allocation. Just as last option, we propose the mass also. Then the actual situation is that in many cases we should look for this economic allocation, because it's difficult, especially when you have two different products, one for with energy applications and the other one for power applications, for instance. So the highly produced through thermochemical or chemical processes, then it's not easy just to make this energy or the number of moles allocation. So we go for this economic allocation. Well, prospectivity. You can see that we propose here the system must be modeled at a future time. It was also explained by Petra. The technical parameters and capital goods and asset product must be prospective, and when performing a comparative study, must ensure that all these technologies are modeled at the same future time implementation. One difference in the life cycle assessment guidelines is that we have included several examples here, because for the three previous one, we have the case studies. But we thought that it was better to put here as an example, because sometimes it's not so easy just to explain how to merge all the different issues, all the different characteristics of the three dimensions. So here, for instance, we have one case study in the social electrolyzer, and in this case, we modeled this for the year 2030, when the social electrolysis technology is expected to reach the maturity. Then the solution side, the resources part of the system was modeled according to the expected KPIs proposed by the Clean Hydrogen Partnership. And the other part, the CSP, the Concentrated Solar Power Plant, operating parameter, the integration between the plant and the soil electrolyzer, and also the reference system about the estimated reformer, where just this extrapolation were based on process simulation tools. In any case, you can find also other examples in our line just how to deal with this perspective. Sorry. Sorry for that. Okay, just coming to the functional unit. In its guideline, we also propose different functional units depending on the characteristics of the system to be addressed. If we talk about having production systems, so we propose that we need to use a mass-based reference unit, but also it's very important to include here high purity, pressure, temperatures, and also we are talking about social aspect. Also, we have to include here the geographical information. You have also the example, in this case, coming from a previous work with the material value here with us, and also with my research group. And for instance, we have also the functional proposal for how to use for fuels and chemicals production. In this case, we propose to use a mass-based functional unit in the case of chemicals, and mass for energy based functional unit in the case of fuels. So this is especially important for the e-fuels that are coming now. Hydrogen is one of the main raw materials used here. So if we want to avoid the use of hydrogen for these e-fuels, this is our proposal. And again, we have to include all the technical conditions of this hydrogen along with the geographical, and in this case, temporal information. Okay. Also, in the case of fuels, the energy quantity must be clearly stated. We propose to the net calorific value. Also, we have, this is coming from the environmental guidelines. We propose the different scopes for it to be studied. We have proposed independent production, different, in this case, 6 calculate the scope that we include the production and use. Then we have this also called break. For instance, we have here the system boundaries for addressing hydrogen production and use. Then we have to compulsory to include the cloud to grade approach, and all the relevant flows will be included in the assessments. Here, for instance, the obtaining of green methanol using HAP. Also, about data quality, this is just a suggestion because this is a relatively complicated issue for beginners. So that we have also here some suggestions how to deal with the data quality. In this case, in the example, we are using the theory that you can find in the software OpenLCA, that is the software that our C2 is based on. A picture, I will not go in detail. To our guidelines of the whole definition, the section of authorities, etc. And also, we want to go just to define what is the resumption, just how to select the multi-criterial decision analysis method, and also how the results from the environmental, economic, and social aspects is integrated. If we want to wait and so on. I think that it's better you can put this in the final guideline, because it is just a way that to have the final outcome, the final result of the life cycle sustainability assessment. And that was all. So it's just a quick summary of the sustainability guidelines. So thank you. Any question? I think we can go for the more practical part of our presentation about the case studies.
Thank you. So, yes, just one overview from my side because the presentation of the guidelines by Javier. And right now I would like to invite Julie to present the case studies of the SH project. Okay, that's fine. So thank you, everyone. So I'm going to present our presentation prepared by my colleague Pierre Rigaud and Emmanuel Kans that they couldn't join today. Pleased to make this presentation. Well, it's about the presentation of the SH2E case studies. The objective of this case studies really to this one was really to apply to this life cycle sustainability assessment of hydrogen system. The idea applied to case studies. So the idea was really to check the applicability and relevance, as well as potential for improvement of the guidelines, and else to evaluate the sustainability and performance of two hydrogen technologies and benchmark it against competitive solutions. Well, so regarding the case studies, we choose two case studies. So the first one related to the production of hydrogen through solid oxide electrolyzer. So this technology required steam and electricity. So it was coupled with a concentrated solar panel plant located in Spain. And we decided to choose another case study related to mobility. So the use of hydrogen in a fuel cell electric vehicle for transportation. Both studies were benchmarked with competitive solution regarding the production. That was a solution that involved steam methane reforming located in Germany. And concerning mobility, so that was in comparison with battery electric vehicle. And so these four case studies were evaluated through three types of evaluation. So the levelized cost of assessment, life cycle cost, and social LCA. And so they were assessed by different partners of the SH2E projects. So before presenting you the result, I will just maybe saying that the result you will see is not going to be used to guide decision making. Meso or macro level they have to be understood as really case specific, and especially for the first case that is really a prospective assessment. And so it's really relying on hypotheses that will be locally and temporally dependency. Well, so going through the case study one, relying on the hydrogen production with a coupling with this concentrate solar panel. So for the LCA, so we define the functional units, really applying the guidelines, the recommendation of the guideline. So we define the follow as follows. So the production of 1 kilogram of hydrogen, and we define the quality of this hydrogen related to its purity, pressure, and temperature. So it was modeled considering the horizon 2030, because we considered that at that time this technology, high temperature electrolysis, would be mature technically, so on the market. And And so it was really a prospective assessment. So concerning the LCA, for instance, it was used premise evidence in order to produce a kind of prospective background database as well, especially regarding the electricity mix that will be inspired by future energy scenarios. So here you have the different size of high temperature electrolysis system as well as CSP. Optimization tool was used to fix really what would be the best size of both systems to have the better coupling in terms of economy and performance. Concerning the boundary, so the assessment follows rather to grade approach, considering starting from the raw material extraction to make the electrolyzer, the CSP system, until release the deliverable of this hydrogen at a good pressure, and handling as well the end of life. That was considering the cutoff approach. And concerning the method for the assessment, so the environmental footprint from the European Commission was applied. So here you have, I will say, a list of impact categories, and on the figure on the right side, you have the carbon footprint contribution of the main activities, representing only the ones that have an impact superior to 1%. So what we can see is that the electrolyzer is not part of this presentation, so it's under the 1% contributor. It's really mainly relying on the production of steam and electricity, as you can find the CSP system as well as the electricity grid that was used for the auxiliaries of the system. So we did this. We did the same for the benchmark solutions. So with the steam methane reforming system, and so we were able to compare it regarding the different impact categories, relying on the climate, the carbon intensity of the hydrogen. So we found, I would say, the typical value, and really the importance of looking at electrolysis and renewables, as we have a low carbon impact on the hydrogen, around 1.3 kilogram of CO2 per kilogram of hydrogen, compared to the 8.8 relying on the steam methane reforming. So that's it. The solution, the electrolysis solution, is better for has better environmental performance for climate change, ionizing radiation, and ozone depletion. SMR is better for the other categories, impact categories. So we did really the same for two other type of assessments. So here you have the result for the life cycle cost as presented by Petra. So we choose the calculation of the levelized cost of hydrogen here, and so you can have the presentation of the cash flows through the lifetime of the project. That's relying on the lifetime of the 30 years operating of the CSP. And so here you have the initial investment in the CSP system as well as the electrolyzer and the trucks to the delivery of hydrogen. And so you have the expense involved, the cost of the maintenance and also consumption of hydrogen, of electricity, and CSP operation. And so you have here the revenue from hydrogen incomes. And so every 10 years, we have to replace the stack of the electrolyzer and to reinvest in another truck after 18 years. So considering this, really, so we calculate what would be the cost of this hydrogen, really to cover all the expense through the lifetime of the system and to have at the end a net present value equal to 0. So we obtain to do this, the cost of hydrogen would have to be at least 7.6 euro per kilowatt. It is the same exercise with SMR, and we find a value quite lower, less expensive of 1.3 euro per kilowatt hydrogen. But it really depends on the hypothesis of the natural gas. Well, concerning the social LCA, so actually we decided to focus on 3 indicators with a new one that will cover the workers, the society, stakeholders, and as well as the value shared actors as well. And we should then, in order not to overlap with the other indicators covered by the cost and LCA assessment. Found out that in green, that's the hydrogen production step in Spain, and with a main contribution to the majority of social impact due to the high economic flow associated. So we did the comparison with SMR, and we find a big difference with SMR that perform better on the majority of social impact. I think that we will need more time to analyze this result and for the interpretation. Now, we switch on the second case studies that is related to mobility and the use of hydrogen in a fuel cell electric vehicle for transportation. Applying the recommendation of the guidelines, the green box, we define this functional unit with a driving distance of 15,000 kilometers per year. A vehicle that is a kind of family vehicle, C segment for 15 years. That is the lifetime, the standard lifetime of this kind of vehicles. So you have here the main hypothesis, mainly on the hydrogen production. So here we define this boundary that cover, I will say, the 3 main stages of the system, with the production stage encompassed with the production of the vehicles, the fuel cell vehicle, an operational stage with the production of hydrogen as recommended by the guideline, and as well as the maintenance stage expense,
and the end of life that was handled as with credit that was with negative impacts. So as for the first case studies, we use the environmental footprint methodology, and with here the different results on the impact categories. And if we have a look at the result for the LCA, so we have a powertrain manufacturing in clear blue that is really have the most impact on 5 categories, and except on land use that is really relying on the use of fuel cell, and that can be explained by the use of IS. I didn't maybe mention it, but for the fuel cell, we work on 2 scenarios of hydrogen supply. So one hydrogen supply in Spain with PV panel and electrolysis, and another scenario in Germany with steam methane reforming. So here we are in the scenario in Spain. So that's why we have this land use with the use of PV panel, and in water use that is really the hydrogen tank manufacturing that involves the most impact on water use. When comparing this vehicle with the battery electric vehicle, so we have a look first with to the manufacturing step, and we found out that the fuel cell vehicle was slightly better for the climate change, human toxicity, particulate matter, and material resources. And concerning, I will say, the pool, considering the pool stages, were still better in the Spanish scenario for the climate change. For the fuel cell vehicle is still is quite better for this climate change. That's not fully almost the case for the other impact categories. And and the scenario is quite different, and the result is quite different depending on for the German scenarios, with a better result for the climate change for the battery electric vehicle. Explained easily with the production of hydrogen that is produced with steam methane reforming in Germany, in the German scenario. So in the German scenario, and so if we switch to the life cycle cost, we really keep the same boundary and also the same functional unit. And we applied, and so as an indicator for the life cycle cost, we choose the total cost of ownership as this indicator is really consumer oriented, and so you can find here in blue the initial investment in your car, and then you have the operating cost. When we compare the 2 locations, so the main difference rely on the cost of hydrogen with price that is really a difference 3.5 higher when you produce this hydrogen by renewable and electrolysis compared to the steam methane reforming. So we did the same for the battery, and here's the difference between the 2 locations is really because we have in Spain, for instance, government incentive to buy an electrical vehicle. That is not the case anymore in Germany. And so when we compare the 2 vehicles, so we we have a big difference in the investment, but easy to understand this difference because of the difference, the gap of maturity between both vehicles and the lower and with a fuel cell that is not a big part of the market for the moment. Regarding the social LCA, so the objective was really to find the social impact of the hydrogen vehicle. So we decided to do so. We defined the location of the main components, and so we obtained this result with the yellow part that is related to the hydrogen production from fuel cell, electrolyzer, sorry, and also in dark green we have the refueling station, because in that case we considered that we had kind of fleet, and so if this part is so important, maybe that's because the refueling station was underused, maybe, so that's why we such a big impact. And concerning the battery vehicle, so the battery has the biggest impact on different social indicator because of its high economic flow associated, and hence because we consider the manufacturing country that involved according to the SILCA database risk regarding fair salary, child employment, and so when we compare the two, we have this quite big difference between the two vehicles, but we think that it can be explained really by the fact that for the fuel cell we taken into account this the refueling station account for a big part. So we think that maybe the gap could be really reduced if we remove this contribution. Finally, well, to conclude, the idea was really linked with the presentation of Javier. The idea was really to join the three assessments and through to have this life cycle sustainability assessment. And so, following the guidelines established in the SHIP project, we was able to have no major asymmetries among the three evaluations and to be able to produce such figures and we avoid this major asymmetries because we focus on the same functional unit. We define also same goal and scope. So we can just say that we could find some minor asymmetries related to the quality and the granulometry of the collected data are different, especially for the social life cycle assessments. And maybe also we are not in the different way the end of life stage depending on the case studies. To conclude, I will just mention that there is currently a third-party review that is in progress and that will provide more feedbacks. Another point also is that all the inventories, hypotheses and results are gathered in the supplementary information file that will be available after at the end of this project, and I'm sure that will be used in the future project that will test the technologies. Thank you very much for your attention. I have appreciate. Any questions?
Having a additional comment, thank you for the presentation, that we are expecting for tomorrow the stellar review report. So we will incorporate this in this final deliverable. Be a very last minute deliverable. We will just submit it by the end of the project. In any case, after approval, this deliverable will be also
There any further questions? I will review the opportunity. We have received also one question from our online audience. It's related to basically all that has been presented. So the question is whether the guidelines for scaling up methodologies will be also available, and if modularity can be applied to larger hydrogen production plants. So, for example, if 5 megawatts system can also be treated as 1 megawatt units. I would direct it to Javier or to Pedro.
I will begin with the last question. No, I think we can go for this kind of modularity. 5 gigawatts is they don't have the same components as 5 or 1 gigawatt. But you have some PV and so on, so we cannot be treated in that way. I don't remember the first question.
Whether the guidelines for scaling up methodologies will be available.
It's included in one of these yellow boxes. Is included how to do this.
So yeah, I think with this we can just encourage our audience to just get acquainted with the guidelines and study, because it offers actually many functionalities. Are there any further questions for the presentation of Julia?
Because I understand that you're still somehow working on these case studies. You mentioned that you're about to finish, but I could understand clearly the difference of the main results from the first case study between the solid oxide cell and the SMR production, let's say, in which LCA apparently it's much better. The solid oxide, apparently the results show that the solid oxide is much better in terms of kilos per CO2 produced per kilo of hydrogen. In terms of cost, clearly the SMR is more competitive, let's say, according to the results. And for the social aspects, it looks like, but we are still working on it, that the solid oxide cell seems to be better. But from the vehicles, I couldn't grasp this conclusion so clearly. Maybe you can go back to the main slides and you can elaborate it again to get the messages. Just avoid yeah.
This one?
From LCA, yes, between the pure battery electric vehicle and the fuel cell electric vehicle. In terms of social, how can I interpret this figure?
Perhaps I can cover on this also. When we talk about the social assessment, we are taking into account the full supply chain. So, for instance, the main responsible for child labor, frequency or forced labor comes from the family. So, because the amount is low, but the social and economic impacts are high. So this is the main difference with the battery. In this case, the critical commodities you said, the system are affected a lot. The final outcome of this.
So considering the social aspects, your results is that the pure battery electric vehicles are better?
Depends.
Less, let's say,
It depends on the supply chain that you are defining.
Yes, but
Like in this case, the battery electric car performs better. Because, but Julie has commented this. Take into account that this is hydrogen fuel gas are there, but they are not so much the battery electric car. So then some aspects of the supply chain has to be improved just to reach the same performance of this battery electric car. This is the main message coming from this figure. So, as I have commented, social assessment is not a punishment method. So we identify that, for instance, the platinum of South Africa has a big effect here. It's not to say, okay, well, get out of South Africa. It's quite difficult because they dominate the 99 something percent of the market. But it's just to improve the social performance there. If we identify that there is a problem with the child labor, or forced labor, so coming from the European or the companies there, they have to improve this. Okay.
Yeah, but according to the graph that you just showed, precisely child labor, apparently the fuel vehicles. Of course.
Yes, there is also one.
That's the aggregation of the medium risk hours, which is the factor of the cost. And and of course the social aspects behind the people. So basically there's a linear or strong correlation between high cost and these values. So meaning if we're looking at these types of aggregation, this does not mean 115 risk hours does not mean something bad actually. You need to look further into the data. There's something we recommend in the guidelines that's called the direct approach, which means if you break down the medium risk hours, they're actually all coming from very low risk child labor. This is not meaning that it's a high risk at all. So this interpretation is actually more demonstrated in the application report. It shows that does not mean I have high medium risk hours. I should say that, oh my God, this is the social hotspot. No, you should look further and then see where these medium risk hours coming from, because they are an aggregation of very low risk, high risk, and medium risk. Sometimes in the data set that you selected, everything is the very low risk, but you have very high cost. So the multiple of the product of these two multiples will give you a very high number. So this is benefit. So do not take actions, or this is really recommended in the application. Do not take direct action based on the aggregation of medium risk hours.
No, thanks for the explanation. No, I'm really concerned about how an external reader can read.
Exactly.
It's not about the situation. This is fine, but I believe that from that picture it shows the pure battery, and I'm not sure if that's a correct message.
It's not a correct message, actually. And
Yes, so it's a nice solution maybe to the next presentation, because we have, always, I mean, we've seen this a lot. We talked about since we software, and it was always not technical with our presentation, so that we explained. And because it's also just depending on the cost, if you put more effort to make your product socially responsible, pay higher wages, pay higher costs, and that leads to higher incomes. That's of course a bit misleading. Therefore, we have implemented, of course, the guidelines, implement also the tool, different way to calculate all the impacts. Unfortunately, it would be possible to include case studies, but I'm sure it's more from this data.
Okay, I'm just concerned that someone journalist take this picture and they make the story right about the picture without all these extra reasons. Okay, we provide these explanations.
Yeah. I think the only explanations will be the
and once again, it's just examples to test the guidelines.
Yeah, but let's try not to shoot the normal fit.
You're right. We're going to do it for maybe.
But it's not like this is about starting of study, but presenting the research. So just the output of what you know.
Wait, let's see the message on. Are you free to just take that and
I can see tomorrow a journalist saying They are more expensive, socially they are worse, and therefore, what the hell is Europe doing?
La seconda è su larger maturity. As a committed, we need to invest more time, more cost.
I guess that in the boundary condition you have assessed, so you have put a number of vehicles per year, as well as you have the driver range of 15,000 kilometers. I'm pretty sure that you have a number of vehicles per year, but compare apples to apples, not the same conditions.
I'm not aware of how many costs. Can you repeat the question? Because it's about the definition of the case study for the country using.
Yeah, because for example, I heard in the presentation that the refrigeration station was taken into account within the fuel cell vehicle. If I'm not mistaken, I think that additional the electric refrigeration station is also included. All these details that will be in the report.
Yeah,
I wanted to flag that the message that I'm getting is not so nice, let's say, for the housing sector. That's why I want to understand a little bit more what is in a brief, what's the message that the project is sending.
So maybe if you agree, we can follow the presentations, because I think that the discussion will be also much clearer after the explanation of Green Delta, and later we can continue the discussion. I don't know if there are further. Thank you very much.
In any case, one last comment. All the explanations will be delivered.
Okay, so Andreas, actually, you would be so kind to further present.
Is it working? So it works now?
Yes, it was working, but just give me a second. I think that you already woke up the curiosity on the social aspect, and I think that it was a very good introduction.
Yes, so hello everybody from my side also. As CEO, and I'm here with my colleague Ashrakat, who has worked also in social assessment or also gender project. And topic is now tool demonstration. It's not really demonstration because we have the tool on there, but not so we can show the tool, but not here live, but maybe still fine. I have 4 points about the tool, then remarks about the SAE modeling with the tool, and then I think it's interesting, or I thought it's nice to talk about specific features that we implemented in context of this project in the FCA tool, and then I conclude. And about the tool, you've seen this before, but it's principal structure. So we have, of course, spent a lot of time and effort in the project to develop guidelines for modeling hydrogen systems over the life cycle, SLCA, SALC. And I think it's good to have these guidelines, but then typically it's a bit difficult for users if you just say, read these guidelines, please, and then go ahead. Because normally you don't do an SAA study manually, but with the tool. And then it's, of course, if the tool doesn't support these requirements or these suggestions from the guidelines, you're a bit at a loss. And therefore, this is good to have a tool that really supports these guidelines. And then, of course, in the end, leads to here harmonized calculation results. Yeah, and this is a screenshot of the tool. It's really it's a full-fledged SA tool, but specifically developed for hydrogen systems, PHG. And we have it was a decision to not make something like a tool that would also be possible, but basically what I mentioned also in my reply some time ago here in the meeting, we have so many different hydrogen systems that it's really very difficult to fully reflect this in a new tool. Yeah, so because it's really almost endless possibilities, and therefore the idea was to start with OpenSCA, a software tool that we developed since 20 years now almost, but has been really updated and modernized several times. So it's quite up to date. Really broad use. We think the most widely used SH2E worldwide, and very good for generically modeling SA systems. But of course, the tool is created without knowing these guidelines. So therefore, we need to enhance the SA tool specifically for these guidelines. And therefore, you see the OpenSA bottom. Maybe short something about OpenSA. As that we have that's updated because we have version 2.2 snapshot already out since 4 weeks or so. But we developed this since quite some time. It's an open source, very powerful SA tool. Developed only at Big Delta, so but really has 100,000 or so users worldwide. A lot of strong user base in North America, also in China. It's growing a lot, and other Asian countries, and also Latin America. We have many different SA databases, also the Seeker database that we developed, that was mentioned several times, but also Equipment, for example, and also other databases. And it's really completely open source, so this is a free tool that you can just distribute, and that it's really, I would say, better than Grabi, Zimap, or other tools that you know. So that was quite a good choice. So it's not that we say we take this, it's cheap and we need to compromise, but it's really a very good choice for this. And then behind enhance this tool. Maybe this is a bit to we often get asked this why we have this developed as open source. And it's maybe not too difficult to explain this here. We have we started this some time ago, and it really works for us. So it's not that we have a premium version where they really manage it with the product and working software costs something, but really software is totally free. And we get support for developing this further, like here in the project, for example, and that helps us to maintain this. And it seems to work really quite fine. And here, this is a bit funny. It was funny for me. One of the very first industry users was Lockheed Martin, because they said, the US defense industry, because they said we need to use a tool where we can check this full source code so that we are aware that it's no hidden thing or so. And so we have quite some also big industrial clients that use this, which is quite interesting. Yes, and maybe it does not mean some people claim or whatever that because it's open source means that your models are also open and need to be shared. So that's not about the case. So the models are totally up to the user, and there's no obligation. Yes, and only very short about the modeling with the tool. It's really because we built on OpenSA, you can do everything that you can also do with it. With OpenSA, import from different sources, export to different sources, perform full-fledged lifecycle modeling, lifecycle calculation, result analysis, and so on. So that's really, I think, a very good choice. Also, maybe I don't have a specific slide for this for the maintenance later, because it means we don't have one-stop software that is then finding there, but idea is to integrate this in the main OpenSA branch, and then we start already with the 2.1 release, and to then make this available more broadly. And so therefore, this is not just sitting there, the tool, and gets old, but hopefully gets continued. And it's just one short screenshot, which I think is quite a nice feature of OpenSA. This is a screenshot of the life cycle. And you can here really build a very large life cycle and modify this one box with one process. And you see really visually the life cycle can get that. So now, but maybe more interesting and fitting for this meeting to talk about specific features that we developed. And there are 3 main specific features that I would like to use those to a bit, for example, data quality to improve this a bit. But the main 3 features I wanted to talk about is templates that guide you, or like a wizard that guides users through methodological choices. Yeah, and you remember you've seen this several times ago that we have in the guidelines these different boxes that are the green are recommendations, and they are you must do this, and it must be considered. or blue boxes that are it should be done levels or recommendations. And and then we have developed a full branch of the pathway of the different possibilities. So you say you can do this, then you should say this is important like this, and then this should be a function with or all is like good, but that you have a sequence of decisions that you need to do by making the SAA model according to the guidelines, and you are guided through these decisions as usual. And you first start with basically 2.5 cases of one hydrogen production, so the input side, so to say, hydrogen use, the usage side, and both together. And then overall, we had 46 different templates that we tried to capture all these different decisions that are there. This is what I meant. This is it's not the everything, but this is the different things where users are guided through. I mean, first we drew this, and now it's implemented in software. And it looks like this, that you say, can't see this in here, but there's a G button there, and then you start the wizard, and then you are guided through these steps. And it's also like breadcrumbs documenting which steps you follow, so that you afterwards are reminded and it's documented what is your decision that you take, the volume of the hydrogen case. And really this is, we just start this, and then based on this, such a model is being created in software. And of course, then you can refine it further, but this is really, I think, helpful to really better the recommendations of the guidelines. And then of course, you can then refine this, edit this, add flows and whatnot, but then you have a template and the first version that you can start. It's much easier than doing this from scratch without any guidance. In the documentation, we added some more fields there to reflect these points, recommendations from the guidelines. Well, and then it's quite often interesting, and this comes in the next feature also, to use parameters to make sensitivity analysis. So that's of course not specific to hydrogen systems, but it's still quite interesting. You can use it also to switch supply branches, let's say, and for time which comes. Also, you can address what Javier mentioned about functionality by setting different allocation possibilities, so economic, physical, system expansion also, so you can enter a specific vector in cell. And you see then the factors that are calculated. You can compare results based on different allocation factors. We have data quality, as said, was existing a bit or quite a bit before, but we enhanced it, but you can reflect data quality for a life cycle model. You see then this in the results, which is quite nice. That's maybe it. And then comes the third best feature that we are quite happy about. And that is the direct calculation of social index. So we have developed the Trigger database maybe, I remember, maybe 15, 20, 12 or 15 years ago, quite some years ago, and it was always, I found, not really too satisfying, as I mentioned also in reply, for one also because worker hours do not really reflect some social impact. So if you say community is resources of affected of a plant because the plant is using wastewater in the fishing area, so this is not all linked to the working hours spent in the plant, so it's totally different. So therefore, for example, it's not a nice vehicle somehow, so to say, to transport the scale, the social results and impacts. And when I look then, was already around Corona, when I look in the database that we have, and we have some like 80 indicators there, I realized basically you can, it was always, when the method was developed, it was always a statement, well, social indicators are different, you can't calculate them, you can't aggregate them, therefore you need to have a different approach to make the calculation. And I realized it's not really true. From the 80 indicators that we have, you can all of them quantify them somehow. only have indicators that are percentages, so it doesn't make sense to say we have 5,000% unemployment rate, and we have some absolute figures as well. And then we only need to divide the these relative indicators by the overall number, multiplied or scaled by the post contribution, and that gives you the final result for the full life cycle. Yeah, and this is what I call direct calculation. I presented this in the conference also 5 years ago or so, but then we here implemented this in the tool. And this is just already here. It's only expanded for the screen doesn't fit for one branch here, but you get this for all the indicators. So you get here then the absolute result of the indicator for your life cycle. Yeah? That totally unaffected from the price of the product and so on. So therefore, it's quite, I think, a better approach, but misses the distribution across the life cycle. So you don't see anymore that here you can't see this anyhow. Contribution of sector to economic development, 11%, which is quite high of GDP. If this is an average or for the whole life cycle, if this is some extreme cases and some very low cases, or how this is lost. Therefore, we do in addition calculate this here, and this is the risk distribution across the life cycle. So there we see here you have opportunity and risk, then you have very low risk to very high risk, more data, and you see in red always how this is distributed, and that should give you or gives you an overview of if there are the risk coming from an even spread of medium risk or one or a few extreme cases high risk. That's quite, I think, quite interesting and a bit overcomes this issue that this thing is social data. Yeah, that was first special feature. I'm excited as you see. Second feature that's even maybe better and was more complicated is that we found a way to implement time in the life cycle calculation. Peter has summarized this that we found for costing. It really does not make sense to say we cannot know or we ignore time. Yeah, so it doesn't matter if you have income in 30 years from now, it's only in any HA tool so far it doesn't exist, so we can't really calculate over time. And therefore, I mean, there's some extensions or so, but it's really not mainly existing. And therefore, we added a feature to implement now, it's a bit like a simulation to allow calculation over time. Basically, it's something like this, that you specify parameters, and you say this parameter, you can see this from the back, is run 100 times, and you need this 100 times. So the system is calculated 100 times. In this, or can also, and in this 100 times, right, this parameter starts from 1 to 100, and then you get different results for this. Yeah, and this is quite, I mean, it's a very simple example, but this can be extended quite a bit, and we have made quite nice calculations where you can, for example, say, you set up the hydrogen plant, then you have in the first 2 years investment costs, so you have expenses, and then the plant's running, you have profit, and then you can calculate over time because you can make quite complicated formulas. You can see, but here it's if years greater than 2, then it's 1, and otherwise it's 0. So then you can really specify at what time something happens, and can make a full-fledged cost calculation over time and include discounting and so on. And this is really, it's one example. This reflects the guidelines, and it's really making it much easier for users than if you need to somehow do this inside or whatever. Yeah, this is this example here that you see. We have here expenses for setting up a plant, and then we have profits, and then we see also it's not even here increasing a bit, so you can really make quite complicated formulas for this and really reflect your system over time. Yeah, that's it. I think I hope I was able to transport that we have a great powerful tool that is reflecting the guidelines that we developed in the SHEET project. based on OpenSA, which is in turn also a powerful tool, of course. And with results that help users really to reflect the guidelines and follow the recommendations there. Of course, I mean, it's always with a tool. We have used this internally. It's public, it's open source, also developed publicly in GitHub or also on GitHub. We have for now published this on our website. I think it's then at least to put it on the She website, maybe also in other contexts. So we'd be happy to distribute this further. We can talk about this. And we have also social, some of the features have already been taken over. The normal branch of OpenSA, especially the social calculation. And I think it's also interesting, these templates to develop these further, because quite often they have some specific rules for LCA modeling, and DB was tested how to relate specific rules for setting up LCA models, and then to, based on the settings and decisions, create the model as a template for users to find further. That's maybe something that can be expanded. That's it. Thank you, and I'm looking forward to any questions. Yes.
I have a couple actually, but yeah, thanks for very impressive presentation your tool. I understood actually beginning of the tool. I have a curiosity first, and that is how long or less does it take for a user, let's say user with some experience in the field, to complete to make an analysis in the report, more or less.
I mean, I think typically, I mean, you still saw that some case studies haven't fully used the tool, but it's more matter of if you're used to it, like to another tool, and so the hard part is typically data collection. Yeah? So if you have everything ready, then in OpenSea you can make really also complicated stuff in a day, yeah, because the taking and so on. If you take just everything together, it's not taking long time. But typically, data collection takes quite some time. So that's every, let's say, case like this, and that's totally independent from the software, I think. So far, often, but so therefore, let's say, modeling itself is quite fast. We also make complicated case studies. I mean, maybe when you think of how you set exactly the formulas to get the time dependency, so that probably doesn't go right in the first half hour or so. So you need to experiment a bit and look how the cases are, how the formula language is, and so on. But that's easy. Yeah? So that's also a bit, I think, benefit of sitting or building this on top of an existing and mature tool that really has a lot of users and get training every 2 weeks about it. And so that it's not that we can listen to what is thought about for this stuff. You know, so it's quite quite a usable tool, I think.
There's a question related to the social aspect of testing. Since the indicators are given in a common use, so the medium which covers, not the scores, and
not necessarily.
Opportunity or risk or
also not necessarily. You see, it's two. For one, you have, I mean, it's maybe about 9%, but you have, for example, illiteracy rate female. Huh? So that you have 0.85% is that's the indicator. You don't have working hours necessarily.
Okay. Huh? So the question was a bit more high level.
Yeah.
If you see that there is the possibility to calculate the kind of aggregate indicators or single score indicator for total internal like about certain, but it's something that there is something missing.
Yeah, very good. Yes, that is something that, yes, we have talked about this. We have been asked for this for some people in context of SSPD, for example, too. So there are quite some ideas now why if this can't be combined. I think it's more complicated even than in environmental SA. I mean, that of course recommends one single score, I know, but everybody or many people complain that it's not ISO compliant and whatnot in comparisons, and social it's maybe even more difficult because you need to say, hey, I think just take this, I think contribution to economic development and the literacy rate, how important is that? You know, so it's, you can of course easily say, I think 10%, 15% can boost the final result, but then the next person will say differently. So I think there probably some more community discussion needs to take place to get more support for this. It's technically or mathematically, of course, super easy. You can just say, I just define all the indicated rating factors and then, but will not be credited, I think.
Are there any more questions from the audience? If no, so maybe, well, thank you very much.
Thank you.
Again, and now I would like to invite all of you for a lunch. I hope you are hungry. And after the lunch, we will meet again in this room. So at 1:30, we are meeting here for the second part of our event, and we will follow with the presentations of our invited speakers. So also for our online audience, so we will be back online in 1 hour approximately. So please enjoy your lunch. Thank you. Hola, Andrés. ¿Todo bien?
Hola. ¿Me oyes?
Mamá, ¿puedes encender tu sonido? Enciende tu sonido.
¿Me oyes, Gata? No.
Andrés, ¿puedes decir algo? A ver si se te escucha bien.
Hola, hola. Hola. ¿Me oyes? Hola. Hola, hola.
Vale, está perfecto.
Ahí, ¿me oyes?
Sí.
Vale.
¿Nos oyes? Hablamos.
Sí, 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 oigo bien. ¿Tú?
También te oímos.
Vale.
¿Puedes probar cambiar las diapositivas a ver si...
Está sin sonido. Cambia la diapositiva. Me parece que me va hueco.
¿Va bien?
Sí,
Hola, buenas tardes, ¿me veis?
sí, Fernanda.
Perfecto.
No sé, Fernando puede compartir su presentación.
¿Tienes el micro? Vale, Andrés, tú para tu presentación enciende la cámara, por favor, también cuando empezará a las 1:30.
Está... A ver.
Ahora está apagada, pero luego si la puedes encender, perfecto.
Ahí está encendida. Pero... A ver.
O sea, está encendida, pero aún no te vemos. O sea, está en negro, no sé por qué.
Uf, a ver.
Espera, que igual. Yo desde una cámara apagada da igual, ¿no? Espera.
¿Ahí me ven?
No, no sé por qué, pero aún no se enciende. No lo tienes tapado.
De arriba.
No, no, no. Es que yo sí me veo.
Okay, so welcome back again after the short break. I hope you had a good time and you enjoyed the lunch. So right now we will follow with the second part of the final event of the SHIP project. And in this part, we would like to hear the presentation of our invited speakers and experts. And also right now, we would like to start with the presentation of our colleague, Andres Pereira, who is the expert of regulations and PRL in Aragon Hydrogen Foundation. And is precisely right now working on the development of the dedicated roadmap, which will be a document that will enable to create a more uniform worldwide standardization process for the LCSA for hydrogen fuel cells. So with this address, the floor is yours whenever you.
Hi, everyone. Well, my name is Andres Ferreira from Aragon Hydrogen Foundation, and I will be discussing deliverable 7.1 roadmap toward FCH LCSA standardization. The topics we will be looking at are objectives of the task, current context, existing standards and directives, development of European standards, challenge and opportunities, identification of needs and gaps, consultation with experts and stakeholders, and conclusions. The objective of the report is to develop a strategy for creating a roadmap that guides the standardization of LCSA guidelines, ensuring their alignment with international standards and facilitating their adoption across the fuel cell industry. LCSA has emerged as an essential methodology for assessing the sustainability of products and technologies. Globally, there is growing recognition of the need to integrate environmental, economic, and social dimensions in the life cycle assessment. In the fuel cell sector, this holistic approach allows for the identification and mitigation of potential impacts at the stage of the product's life cycle, from raw material extraction to final disposal. However, the current context presents several challenges, including the lack of specific LCSA guidelines tailored to particularities of fuel cell technologies. Additionally, the diversity of standards and regulation at national and international level add a layer of complexity that must be addressed to achieve effective standardization. The current LCSA regulatory landscape include a number of international and European standards and directives that guide sustainability assessment. Among the most relevant are the ISO 14000 series for environmental management, ISO 26000 for social responsibility, and ISO 59000 that set standards for the circular economy. In addition, European directives such as the Eco Design and the Energy Efficiency Directive play a crucial role. However, there is a clear need for specific LCSA guidelines for fuel cell technology that comprehensively address environmental, economic, and social impacts. Development of European standards, I will not go into this topic because Luis and Fernando will explain it better than me. Challenges and opportunities. The implementation of LCSA guidelines in the fuel cell sector faces several challenges, including the lack of specificity in existing standards, the need of harmonization among different norms and regulations, and the complexity of integrating the three dimensions of sustainability in the cycle assessment. However, there are also numerous opportunities of advancing the standardization of LCSA guidelines. The growing demand for sustainable products and regulatory reserves create a favorable environment to adopting LCSA practice. Additionally, collaboration between standardization bodies, industry, and regulatory authorities can facilitate the development of robust and practical guidelines that address the specific challenge of the fuel cell sector. To develop effective LCSA guidelines for fuel cell technologies, it is crucial to identify existing needs and gaps. One of the main needs is the creation of specific guidelines to address the particularities of the fuel cell sector. Additionally, there is a need for greater harmonization among international, national, and regional standards and regulations. The lack of specific LCSA guidelines and the diversity of existing standards can hinder the implementation of sustainable practice in the sector. Having identified these needs and gaps, we have been able to pose questions that will help us determine the necessary actions to achieve our objectives. We will then discuss this question at the round table. And conclusion with this answer to these questions, we will have a clear vision to formulate conclusion and define a strategy for developing a roadmap toward FCH LCSA standardization. Thank you very much. If you have any question, please do not hesitate to contact me.
So, thank you very much, Andres, for this really nice presentation. So as you can see, Andres has not an easy task, as there are many gaps that still have to be addressed before preparing this roadmap for the regulation codes and standards of LCSA methodologies applied to fuel cells and hydrogen. And this is why we would actually like to dedicate this second part to this normative approach, maybe, and normative point of view. And with this, actually,
this exciting meeting showing the final outcome, the final results of SH2E project. I beg your pardon from the very beginning, because as an external to the project, I only can provide not results but my view. And my specific view based on my professional experience and in my professional career activity. So just let me start with the contents of the presentation. That is going to be, first of all, a presentation of Lithium Carbon Hub, that is my company, the consultancy company, and verification and certification entity, Verico, which we also work as auditors. After that, I will introduce conceptual notes about what is a methodology and what is a standard. Okay, just to highlight the differences between the concept of a methodology and the concept of reality of a standard, international standards. The main outcomes from SH2E projects, you have seen it, you know perfectly, but just a view on how we can jump from the methodologies or guidelines from SH2E project to an international European, basically European standard. After that, my view on standardization opportunities in the context of the European Union energy transition, not only related with the European standard, but also with the actual regulation or the standard regulation related with the energy transition. And finally, just a resume of the steps to develop European standards according to what states the CEN, the European institution. So Lithium Carbon Hub, as I told you before, is a consultancy company. It's a German consultancy company. It was founded 7 years ago, but I'm afraid that the members of Lithium, we are not very young. So we have been working in the climate change area since 1999, since the first steps of the international organization of a way to tackle climate change challenge. And as a consultancy company based in Madrid, we are focused and specialized on climate change issues, and also very focused on energy solutions. So we provide services to private companies and public administration, mainly in 3 areas: mitigation of greenhouse gas emissions through technological solutions for developing emission reduction projects, the development of public and private strategies and policies oriented to the zero net emissions and capacity building programs. Also, as mentioned, we work as members. Lithium is a member of
certification entity that is very good. I will explain to you a couple of slides later, which is the nature and the way in which we work with Perico. But obviously, as we are consultants, auditors, we have to take care 2000% regarding the conflict of interest. So we always work considering the conflict of interest and not mixing consultancy services with verification and certification services. So regarding last references to working in Lincoln with standards or methodologies related with climate change, I will provide you with these three inputs for international level, national level, or regional level, so subnational. So between 2022 and 23, we have been working together with another company, Knowledge, for a project for ISO, for International Standardization Organization, in relation with the ISO London Declaration Plan. So in that declaration plan, in the London Declaration Plan, ISO has committed to assess which are the needs to develop a complete climate action, a complete set of international standards that will cover all the needs or the most needs at this moment and in the next future moment to cover all the needs for the market and the national level related with climate action. So that is the work that we have done, not only assessing the complete set of 24,000 standards at ISO level, but also making a prospective market analysis within and without the ISO community, and just to detecting 12 key areas in which new standard needs to be developed. For the Spanish Climate Change Office, that is part of the Ministry of Ecological Transition of Spain, between 2021 and 2022, we have been making a complete review of the methodologies for calculation the emission reductions that are coming from climate projects. Climate projects is a domestic system that covers specific emission reduction projects in non-EU ETS sectors, a few sectors. So there are methodologies for calculation, ex ante and ex post these emission reductions, and also there is a verification standard that has been reviewed to adapt. Finally, a long project done for the regional government of Andalusia in the south of Spain, that is, together with the University of Cádiz, the creation of a Andalusian certification standard for emission reduction coming from blue carbon projects that are developed in the Andalusia coast. As I told you before, we are members of Perico. Perico is a pure certification and verification body. We work all over the world, specifically in all the European space, by accreditation by the German accreditation entity, DAX. Basically, we work in related with greenhouse gas emissions, emission reduction projects, and energy management system. So those are the ISO standards that we have in our accreditation. So we can be working in the environmental reports and carbon footprints of emission reduction projects, product footprint, and energy efficiency systems. Our office, native office, is listed in Bavaria, in Germany, and we have the status of a cooperative. So that's something that creates some difference with the rest of the certification entities that are working in Europe. We are just a few of group of experts. I mean, we have right now 26 members in Perico, not only in basically Europe, but also in China, Turkey, Kazakhstan, and the Emirates. And also we have some of us, including the founders of Lincoln, that are part of the set of verifiers from Perico. We have completed the qualification to certify the production of
renewable hydrogen and also the production of the renewable fuels of non-biological origin. That is to be completed, I think, with the qualification of 35 to make this work on behalf of the European Commission. Saying this, I'm making this presentation of our activity. When in capacity building projects or in we talk about this in master courses in the university, I like to point out which is the difference between a methodology and a standard. Okay? Sometimes there is no clear where are the borders, where are the differences, and basically we look for a definition of a methodology. There are many of them, but we can say that a methodology is a conceptual frame. Okay, so it's a conceptual frame that governs the way in which the methods and techniques that we use usually are applied. So those methods and techniques are applied during a research, a design or a calculation process. So we have to obtain a valid result and a result that needs to be reproducible for third parties, for external ones. So it is very clear for you all what is a methodology or a guideline. More or less is we're in the same level. So finally, a methodology is materialized in a document. The document is the document of the methodology itself, okay, that could represent the best result of, for example, a project like SH2E, but not necessarily reflect the consensus of an international group of experts. That's the main difference between a methodology and a standard. Not the only one, but the main difference. So you may have the best methodology possible in a certain field, but not necessarily reflects the opinion of externals. Okay? Externals, they can reproduce all the results, but they can or cannot agree with exactly with the methodology itself. So this is the big difference. And in some international schemes, for example, in schemes for climate change under the Climate Change Commission of United Nations, the methodologies are necessarily approved in a peer review process. So different experts are assessing, and finally, validation and verification body accredited by UNFCCC make the evaluation of the methodology. So it needs to be approved or not. It's also one of the differences with between a methodology and a standard. So coming to the standard, what is in a standard? There is a very short and very clear definition that is provided by ISO in the web page that I like reading a lot. That is basically the standard, the international standard is the result of an international agreement among a group of experts. Okay? And it's the formula to make the best way to do so. It's very simple, very intuitive, but it's a self-declaration of the best way, first of all. And second, what is very important is the international agreement in different kind of experts. But we are talking about a European project funded by the European Union. We should take a look to the official definition that is coming from FENCELEC. Okay, so the European standard bodies, together with the ETSI, define a standard as a document that is established by consensus and is approved by a recognized body. Okay, in this case, a technical committee inside FENCELEC provides for common and repeated use rules, guidelines, or characteristics for activities. Okay? So in this case, we have a clear frame. The standard must be based on consolidated results of science, technology, and experiments. So it is the best case. It's a perfect case for SH2E project. And the development of the European standard, or finding the European standard, is governed by the principles of consensus, openness, transparency, national commitment, and technical coherence. So at least, in my opinion, three or four of the requirements from the to develop a European standard right now accomplished by action. Just my personal. Okay. So the outcomes of the project will be perfect. So we have the 4 guidelines documents. That is the document of guidelines, which should be the document of the methodology itself. Okay. We have also the 2 case study, which is not an issue. I mean, it is very important that the methodology has been tested and validated by a third party, which is not frequent with all methodologies that are presented for standardization. Okay. And also for me, it's very important that the standards, the documents, the outcomes from machine have an initial structure that is, let's say, in a high average equally to a standard, because specifically the guidelines have following in the structure ISO 1440 and ISO 1440. So according to my experience, for the first requirement, we jump from a methodology to a standard, international standard. Let's say that almost 20% of the work, the necessary work, is done. Because sometimes the methodology has their own structure, their own architecture, their own ordering the points that has not followed any international guidance or international order. But in this case, the guidelines have this structure, this architecture. So it is very important because from the very beginning can be easily understood by the technical bodies and technical committees that could make this transformation from the method, from the guidelines as a technology to the international. And in my, this is a very personal thing. From now, this and the next slide. So not only for a standardization opportunity can be identified, in my opinion, in the outcomes of SHE. First of all, we have a credible big quantity of regulation related with the new energy transition. And I'm talking about not only climate change. I'm referring to energy transition because we have to challenge both climate change and also the independence of Europe from external sources of energy. Okay, so outcomes from SHE could enrich many parts of the actual let's say frames of regulation as the Recovery EU, the Roadmap 2040, the European Engineering Strategy, and why not CBAM, the Carbon Border Adjustment Mechanism, which is based in right now in the analysis and evaluation of the carbon footprint for external products, for a certain number of external products to the European Union, okay, and created, let's say, a carbon tax. But the methodology that are adopted, that are creating the European Commission, could be really taking, from my point of view, very interesting points from SHE. Jumping to the European Innovation Fund and the similar schemes that we will have in the future. We need only 6 months to reach the beginning of 2025. It means that we have 25 years in front of us to reach the net zero of the European Union. So many things may happen, many things must be done from now until that moment with the carbon neutrality, and also the project selection, the approval criteria in the area of obviously of hydrogen projects to include outcomes from SHE, or also if in the case of European standard could be done from the SHE guidelines, the use of this European standard to evaluate the goodness of these projects that are looking for funding at this innovation fund or the next funds that will come to substitute the innovation fund. And for me, that we are now dealing with this demonstration of the do not cause significant harm, the DNSH principles. In this case, the life cycle analysis that is coming from SH2 play a definitive good role to improve this demonstration of the DNSH principles. Do not cause significant harm must be demonstrated by projects that are requesting funding from the European Recovery and Resilience Mechanism. This mechanism is the main part of the main tool of the next generation funds, European funds, and this means a great quantity of money. And right now, many projects from the national level are trying to demonstrate that they do not provide, they don't cause a significant harm to the environment. So that could be also extended to cost analysis and also to social, the social area. So she is, for me, obviously a very interesting tool to implement the demonstration of these principles. Because right now I have to say, for us as validators, we find this very simple to demonstrate. I mean, very easy for the practice. Sometimes the demonstration are not very accurate, but that demonstration is done according to the rules, the existing rules. So the problem is not the demonstration. The problem is the lack of lack of consistency of the system rules within the European Union. So we have control right now, but for the near future, I think that it would be a very important opportunity to enhance to make a better demonstration of these principles. And with this, I am done because I think that there is another member of the external conference part that will explain this, but this is the roadmap, let's say, that should from the starting point, okay, in which should be done a proposal to by a European norms to a national standardization body, or directly to a technical committee that now can exist in the level of the CEN, the standardization body at the European Union. And this is the way in which, let's say, between 2 years in the best case, the very best case, to 5 years in the normal case, we have the creation of a standard coming from a guideline. And just one thing, in my experience, once we have a methodology, as you have been working on it, you cannot expect that the result of the standard will be 100%. Maybe your son will be much different than the other guy that is coming from the standardization and committees. Okay? But this is something that we have taken. And that's all. So thank you very much for your attention. And
Thank you very much. Very nicely addressing and for a very nice synthesis of how important is the standardization process. Maybe the questions, if you agree, we can leave them for the roundtable, so we'll have actually more time to discuss. And right now, we would like to follow with another presentation. So our second invited speaker right now, Antonio Valenti from EcoInvest, will present on the economic considerations and harmonization initiatives to support the decision making. So Antonio, the floor is yours. The computer doesn't have a much carry right now. So your presentation must be very long.
This will be the side, but
It's different, right?
yeah, looks like.
Okay, let's see. It's all
Okay, yeah. So good afternoon to everybody. Thank you for inviting me to this the final event of the SH project. So I'm Antonio Valente. I work today in England as a project manager, and I've been working in the field of sustainability since for more or less 10 years or 15 years if you consider also the studies. And I'm working in this field from different perspectives. First as a student, then as a researcher. Then I joined as a researcher when I was in there with Javier and Diego, working on sustainability assessment of hydrogen, and then I joined the European Commission at the JRC in the first group, and then I followed the topic of sustainability from the policy making perspective, and now in England as a database supplier perspective. This is the overview of my career work. And today I'm providing you an overview of what is my experience in this field, also on hydrogen, and hoping it could be interesting for you. First, the word sustainability, sustainable sustainability, is a very catching word today. We know that there is in many areas there is an increasing interest. So this is in research, but also in industry, in financing, in policy making, and many other aspects. This is a very easy trend that can be extracted from Scope results. I found a meme on sustainability that I couldn't put in the slide, but there is this nice meme that in 10 years or 20 years, 99% of the word in an article will be sustainable or sustainability. There will be that's the trend of sustainability. That's what's in it. And yeah, this word sustainability is often associated with environmental related aspects, so green, environmental friendly, or carbon free, so on. And this raises actually concern to the actual meaning of sustainability. What it is. And the word sustainability reminds me also to the meaning that it has in music. So in music, the sustain is the ability of an instrument to maintain a note over the beats. And the sustainable development should be, for me, I in this concept because the sustainable development is the ability to maintain the development over the time, over the generation. So that there's not to be the development just for one window, but just for many different generations. That's somehow inspiring to me. And still, when it comes to sustainability, this is a slide that I recycled from the time of there. It was nice. I love this slide. Okay. Sustained by whom? So something that has to be sustained also by the environment, by our planet, our home, by the economy, by all the stakeholders of the economy. The development has to be sustained by industry and financing also, and by the society, by the different stakeholders of society, by local communities, by workers, by all the society. And the ability to manage these aspects is highly appreciated today by investors, banks, funding institutions from one side, and on the other side also consumers are increasingly caring about the sustainability aspects of the goods that they are using or buying. They ask for transparency of the product that they're on the environmental impacts of the product that they're buying at different stages, how many resources are used, what's the final fate when the product goes right to the end of life, and so on. And also they care about the social conditions under which the products are produced. And this makes clear that sustainability is a complex topic and requires the life cycle. And when it comes to policy, the life cycle perspective is becoming is important of the policy because the life cycle perspective allows to identify hotspots, trade-offs, the shifting between indicators, between life cycle stages and so on. And if we look at this implementation of life cycle assessment into policy, we see that there is life cycle thinking into policy. We see that increasing interest and increasing implementation of this life cycle thinking into policy. Since in the last 3 decades, basically, this is a nice study by the GRC, by the unit where I was working in also, and it makes clear that there is an increasing implementation into policy of the life cycle thinking. Since starting from the ego labeling regulation until the last development of, okay, this is not applicable because it's 2021, the article, but until the last implementation in the European Green Deal, which is the response of the European Union to the 2030 Agenda of Sustainable Development. And it was mentioned, for example, recently there was the Green Claim Initiative that recommends the implementation of life cycle thinking into when it comes to substantiate green claims such as this is green, this is sustainable, this is carbon neutral, and so on. And if we focus on energy, here we see also in the implementation of policies related to hydrogen, for example, energy, also mobility, and chemicals, they are recommending the implementation of life cycle thinking. And this is where the SHE project can play a role to support supporting the implementation of life cycle assessment into this guideline can actually be a support for policy making in the field of hydrogen or policy implementation in the field of hydrogen. That's clear where the SHE project can play a role. And yeah, this is quite part of the work that we performed when I was at India, and yeah, this was extensively discussed today, but when starting from the research in the literature, we found an extensive number of case studies applying the life cycle perspective to hydrogen energy systems for the environmental aspects, while the case studies for social aspects were very scarce, but now you are also implementing new case studies that is really important to understand which are the common methodological background to assess the performance, the sustainability performance of hydrogen. But main message is that we need a common background, and to define a common background, we need case studies. And at the time, case studies were available, so a sufficient number of case studies were available only for the environmental part, and we built at the time for the environmental part an harmonization protocol. We started a harmonization initiative there, basically. We defined this protocol, we applied this protocol, and we analyzed the results. And here I don't want to start a technical conversation, but one of the key results is that we analyzed the expected correlation between the two indicators of global warming potential, cumulative energy demand, so the energy consumption, and the expected correlation was significantly increased by 30% after harmonization, indicating somehow that harmonization concept works. And then we were happy with these results, basically. And yeah, this is where my service there ended. And then I joined the European Commission after India, and from there also I realized that the harmonization, so that to set a common background for different products is very a priority also from the policy-making perspective. There are, for example, PCR development, or I worked in the battery regulation. In the battery regulation, for example, there will be mandatory declaration for the carbon footprint for batteries that once big to put in the European market. Then, so it's important, but it's more important because there will be also thresholds for those markets, for the carbon footprint, and this is very impacting for industry, for industrial market, but also for transport, because you can imagine that you cannot sell your product in the European market if you stay over a certain threshold of carbon footprint. This is very impactful, but this is also important to achieve the goal of the European Green Deal of carbon neutrality by 2025, 2020, and then, and also last but not least, also from the perspective of the life cycle database provider, it's important because we want to respond to many use cases, to different standards, and we want to cover all in the best possible way the needs of the users, of the database users, and also to help them to make well-informed decisions. And